Alright, so at the end of class yesterday, I think I had you working on the bottom two problems here, but we didn't check them yet. So we're going to go over these two at the bottom, see if you got correct answers or if you got stuck. We'll see where you got stuck at, and then we'll go on from there. So these bottom two problems said to rewrite each of the following expressions as a single exponential expression in the form of a to m, so some base to a power. So for the first one, we can see they have different bases, but we want to try to make them the same base. So what are we going to try to make both bases? Do you think we're going to make them both 5, or are we going to try to make them both 25? Yeah, we want to make them both 5. So 25, how can we change that to 5? Marie? Square root or what? What'd you say, sir? Yeah, make it 5 squared, yes. So we're going to change the 25 to a 5 squared. So it's going to be 5 squared in parentheses, and then the 3x plus 2 is still there, times the 5x minus 2, and that's all raised to the third power. Now we have a power to a power and power to a power. So from yesterday, we need to multiply those together. So the 2 times the 3x, 2 times the 2, x times the 3, and negative 2 times the 3. So we get 5 to the 6x plus 4 times 5 to the 3x minus 6. And how do I get my final answer now that I have same bases? Marie? Don't add the bases, add the exponents. Yep. The bases stay the same, so you're left with 5, and add the exponents. So 6x plus 3x, you get 9x. 4 plus negative 6, you get negative 2. So 5 to the 9x minus 2 is your final answer. Any questions on the first one? All right, let's take a look at B. Are we going to try to make the bases 2 or 8? We want the bases to be 2 or 8. Ashlyn?
2.
Yeah. How can we make an 8 into a 2?
2 cubed.
2 cubed, yes. So we're going to have, and I'm going to do two things at once. I'm going to change this, instead of a third root, I'm going to make it to the 1/3 power. So I'm going to have 2 to the third, still to the 2x minus 1. And then over 2 to the 3x minus 6, all raised to the 1/3 power. So I changed the cubed root to a power and changed the 8 to a 2 cubed. Now I can multiply this power to a power right here. So I have 2 to the 6x minus 3 over 2 to the 3x minus 6 to the 1/3 power. Now I really could go about this two different ways. What's one possible way I could solve next? Or what could be a possible next step? There are two different ways I could go about doing this. Marie? Okay, I could subtract these exponents because I have like bases and then take care of the 1/3. Or I could take care of this 1/3 first, and then whatever I have left, then I could subtract. So I'm going to go ahead and take care of the 1/3 first, because I have 6's and 3's and 6's and 3's, and with a 1/3, something's most likely going to cancel out and make it easier. So again, we're multiplying these. So I have 6x times 1/3, negative 3 times 1/3, then 3x times 1/3, and negative 6 times 1/3. So when I multiply those, I'm left with 2 to the 2x minus 1 over 2 to the x minus 2. So that 1/3 simplified those exponents. Now I'm left with same basis. Yeah, go ahead. So again, right here we have power to a power and power to a power. because you can distribute, this could be 2 to the 6x minus 3 to the 1/3 over 2 to the 3x minus 6 to the 1/3. And from the front, when you have a power to a power, you multiply them. So I just took, okay. So if you look on the front, we have all those rules. So the 6 times 1/3 simplifies to the 2. Negative 3 times 1/3 is negative 1, and that's what I did with both of those, okay? Yep, no problem. Now, when you have division with like bases, you subtract your exponents. So we have 2x minus x, so we're left with 2 to the x, and then we have negative 1 minus negative 2, which changes to plus 2, so we have 2 to the x plus 1. 2 to the x plus 1. Any questions on that one? So really this setup that we went through here, creating same bases, is really going to help us on the next part of the notes, because what we're going to actually start doing are solving equations. We're going to have bases on each side of an equal sign with exponents, and we're going to have to arrive at same bases so we can use the exponents to solve for x. So any questions on these before we move on? Alright, let's go ahead to the next page then. Alright, it says rewrite each side of the following equations as a single exponential expression of the same base. Then solve the equation by setting the exponents equal to each other. So what they want you to do on each side, you're going to do to each side what we just did on the previous page. So for the first problem, we need to write both of these bases as the same base. So what base do you think we could turn both of these into? Right? 3. How do we change 27 into 3? Yeah, 3 cubed. And again, remember that just changed to 27. We still have the x minus 2 on the outside. 9 changes to 3 squared. And again, don't forget the 2x plus 5 is still on the outside. This is only replacing the value of that number. So now we have the same bases. Remember, you have to have the same base to do any exponent work. So now we have power to a power on this side and power to a power on that side. So we can multiply those together. So 3. Then we have 3 times x and 3 times negative 2. 3x minus 6 on that side. On this side, 2 times 2x and 2 times 5. So 3 to the 4x plus 10. So that's step 1. That's what we've already done on the previous page. We got like bases, and we simplified so we just have a base to a power, base to a power. This is what we want. We want the same base to a power. Now it says since we have the same base to a power, we can simply solve for x by setting the exponents equal to each other. So we can take 3x minus 6 equal to 4x plus 10, and we can only do this when the bases are the same. And now solve for x. So now you just have an algebraic problem. Go ahead, solve that for x. Anybody find x? Ashlyn? Negative 16. So that is the value that if you plug back into the original, makes that true. Negative 16. Did I lose anybody? The concept makes sense? Again, it's important to have the like bases. So that's why we did all that practicing on the previous page to find like bases, because it leads us to be able to solve these problems. So let's go ahead and try B, the one on the right here. So we have 1/4 and we have 8. What bases do you think we could have in common with these two? 1/4 and 8. And I would maybe think of the 1/4 as bringing it to the top, bringing that 4 to the top. So what value, what number do you think we can change the 1/4 and the 8 to? Right? 2. Yeah, that's what we're going to do. So we can get a 4 by 2 squared. If we have 1 over 2 squared and we bring it to the top, it just changes that to a negative exponent. So 2 to the negative squared is the same thing as 1/4. And again, we still have the x plus 2 there. So just using exponent rules. Equals, well, if I want to change an 8 to a 2, that's the same thing as 2 cubed. So 2 cubed. And I still have the x minus 4. So again, I'm at the same point I was over here. I have like bases. I need to take care of my power to a power and power to a power. Then I can set them equal. Negative 2 times x, negative 2 times 2. So 2 to the negative 2x minus 4. 2 to the 3x minus 12. I have like bases to a single exponent, so I can set them equal to each other. Negative 2x minus 4 equals 3x minus 12. Go ahead and solve for x. Anybody have any luck finding x yet? Ashley? Yep, 8/5. 8/5. Any questions about that problem? All right, do you want to try C together, or do you want to give a try on your own? What do you guys think? You guys think you can try that? All right, so on that one, I'll give you a hint to start out. I would start with changing the square root to a power, because you're going to have to simplify that side all the way down. Again, you need a base to an exponent on each side. So change that to a power. And to get started, what do you think you're going to make them both? What are the bases going to be? 2, yes. So give that one a try. You need to have your bases as 2 and change that square root to a power. If you want to work with your partner, that's fine. If you get stuck, ask questions. You can check your progress up on the board. Did anybody find an x value yet? Any luck? Ration? -4. Yes. There's certain steps you could do differently. What steps did you take?
I squared the right side.
Let's see. Did you squared both sides?
Yeah, sorry, yeah.
Okay. Well, mathematically, that's going to work. If you square both sides, you're doing the same thing to both. So you could do that.
Okay.
Did you change? So you would have changed that power of 3 also then.
What I did is I powered it by the 3 and then by the 2.
Okay.
And just like as the same side.
Okay.
Left side is done.
Yeah, that's another way of doing it. Do we have any other questions on this example? I don't want to move on if you're still stuck on it or still working on it. All right, let's look at example D. So on the left side, we're going to have to do a lot of simplifying before we get it to a single base to a power, but that's what we need to do. Each side needs to be a base to a power. What is the common base you think we're going to have in this problem? We have a 4, 8, and a 16. 2. We can make those all powers of 2. So the 16 would be 2 to the 4th, 8 is 2 to the 3rd, and 4 is 2 to the 2nd. So go ahead and change all of your bases and try to simplify the left side and simplify the right side and solve for x. So go ahead and give that one a try. The marker is kind of dying on me, so let me know if you need something read to you. And was anybody able to find the x value for this problem? Good. Yep, 9/5. Good job. 9/5. All right, so far with A through D, any questions? Anywhere you're stuck? All right, so we have one more problem before we move on to using the graphing calculator. So the one at the bottom of the page, we can still do the same way that we were just using. So if you want to go ahead and give the one at the bottom a try. Again, this one you want to get as a single base to a power. So the base you need to get it in is 2. So the left side's already there for you. But you need to be able to change that 1/2 to a base of 2. How does that 1/2 change to a base of 2 instead of 1/2? 2 to what power? Rebecca? Yep, 2 to the negative first, and then you would have that to the x plus 1. So go ahead and solve that one for x also. It's going to be the same method as up above. Alright, what did we get out there for an x value? What x makes this equation true? Right? Sorry, what was that? That's not what I got. Did you have the same steps up to this point? Did you have this to the negative first?
I see why I did wrong. Sorry. It should
That's
be
okay.
X minus equals
Negative 2, yes. X equals negative 2. Does anybody else have any questions about that? So again, everything on this page was done the same way, trying to get like bases. That way you can use your exponent rules to solve for x. Alright, once you're done copying that, let's turn to the back. So on the back, we're going to have to make use of the calculator. And that's because we're going to have two functions that are equal to each other that we want to solve for x, but we can't make them have the same base. All of these ones we've done so far, we've been able to manipulate it and give them the same base. But as we turn to the back, we're going to have some problems that we can't do that. To solve exponential equations, both sides of the equation must be written so that the bases are the same. However, sometimes this is not possible. For example, in the equation 2 to the x plus 3 equals 3 to the x plus 4 minus 1, the bases are 2 and 3, neither of which can be rewritten as a power of the other. Therefore, at this point, the only way we can solve this equation is to graph each side of the equation in the calculator and use the intersect function to find the point of intersection, which we showed previously in the solution to the equation. So they give you 6 steps here, step-by-step direction on how to plug it into your calculator and how to find the answer. They also provide the answer so that way you know if you get the problem right. So I would like you to use your calculator. If you want to work with your partner, that's fine. Work your way through these steps. They tell you what to plug in. They give you pictures of the calculator so you can see what it should look like as you go along. And make sure you can arrive at this answer down here. Make sure you get the same answer they get. Once you finish this example with the step-by-step directions, there are 3 at the bottom. That's what I would like you to do after you do this one, is work on those 3 and get decimal answers for each of them. I will give you a hint on the bottom. 2 of them on the bottom have 1 answer, and 1 of them at the bottom has 2 answers. So 2 of them will have 1 answer, 1 of them will have 2 answers. So go ahead, use the rest of the time you have here to solve these, and we will check these answers before you leave today. Again, we have plenty of time here to work on these, so if there's something you need help with, if the directions aren't clear or it's not coming out correctly on your calculator, call me over. I'll look at what you typed in. Maybe you put something in incorrectly, so I can check that for you. But again, they give you step-by-step directions exactly what to plug in. Anybody else having trouble with their calculator? Again, when you get to the bottom, find those decimal answers for those bottom 3 problems, and I'll put the answers up to those before we leave today. Do you have a question? Now for those bottom 3 problems, you may have to move your window a little bit, possibly to check some of those. Still have plenty of time. You still have like 8 minutes or so keep working through these. If you have completed the first one, I did put the answer up there for the first one that you can check. If you didn't get that, call me over, I can help you. corrected answer to the second one up on the board if you want to check your answers to that. Since the first two only had one answer, make sure when you're solving on the third one, you should get 2 answers for the third problem.
Yeah.
Thank you. Anybody having trouble finding both answers for the third one? Did anybody else get a different value for number 2? Or did you get the answer that was up there? Do you still have that one in your calculator? And then if you want to go ahead and check your last answer. Again, we have some time, so if you have questions, call me over, but this is where we're going to end today. You can use the rest of the time to work on homework if you'd like. Some of you already started that. That's good. But these are the final answers to these. Again, these ones are calculator ones because you cannot get the same base. So if you can't make it the same base, you can use a calculator in the intersect function to help solve.